Greetings to all. This is Ranjini working as an assistant professor in the Department of Computer Science and Engineering at RMD Engineering College. In this lecture, let's see about a stack. Stack is a linear data structure that follows last in, first out principle, which means here, look at this picture, a number of books. Here, the book which is inserted first will be the last book. Last book is inserted at the first. Now, if I want to insert one more book, means I'll place at the top only. Top only, I'll insert the book and the deletion. Here, the delete. If I want to remove the book, means first book I'll remove first. So the deletion and insertion happens at the top of the stack here. In stack, what happens is deletion and insertion happens at the one place, which is at the top. So last in, first out means if I am going to delete a particular number, the element which I was inserted last will be deleted first. And these are the applications of the stack, that is string reversal, redo and undo operation, recursion, backtracking, expression conversion, or the application of the stack. What are the standard operations the stack can be in the stack we perform is push, pop, is empty, is full, peek off, display. These are the standard operation we perform in the stack. Push up, which is inserting. Push means inserting an element. In stack, we will not call as insert, we call it as push. Inserting an element into the stack is called as push, and pop is deleting an element from the stack is called as pop. Is empty is whether we are checking. Suppose if you want to perform any operation, suppose if I want to delete an element from the stack, which means if I want to pop an element from the stack, means I'll check whether the stack is empty or not. That is empty. So is full. Is full is performed while inserting an element. Imagine a stack size is 10. Already have placed the 10 element in the stack. So each and every time if I'm inserting an element, if I'm trying to insert the 11th element, means I have to, for each and every time to insert an element, I'll check for is full condition. If a stack is full, means I cannot insert further element. Is peek off. Peek off means displaying the topmost element in the stack is called as peek function. So push is insertion, pop is deletion, peek means displaying the topmost element. So display is obviously displaying all the element in the stack. So push operation. Now, so before inserting an element in the stack, we have to check for full. Whether as I told you before. So first, before inserting each element, first if I'm inserting the first element, means what we have to do is I have to check for full condition, whether the stack is full or not. If the stack is full, means I cannot insert further element into the stack. So that particular condition, if the stack is full, means we call it as overflow condition. And next what we have to do is we initialize a stack. Initially we will set the value of top to be -1. Look at this picture, the top value is -1. So if I'm inserting the first element, means first what I have to do is I have to increment the top. I will make a top value to +1. I will increment the top, that is top will be equal to 0. Top plus top will be equal to 0. And if the stack, this particular name of the stack is stack, array of top, I will insert the value, which means array of 0. Right now the top value is 0. So array of top stack, if the name of this is a stack, means stack of top, which means on the stack of 0 I'll insert the number. Now if I want to push 20, what will I do? First I'll increment the top value. So now my top becomes, now right now in this step my top value is 0. In the next step the top value becomes 1, and I'll into the stack of 1 I will insert 20. As like that, to push 30, first we will increment the top value, then only we will insert the value in the particular stack. Now here we have declared the stack size to be 4. So here what happens is at this position my stack is becoming full. Now if I'm trying to insert the next element, what happens if I'm trying to push one more element 50 into the stack? So first I'll check for is full condition. So what will it return? It will return the stack is full, so I cannot insert further element into the stack. And the next operation is pop operation. So to perform pop operation, what we do is first we will check for the underflow condition, which is empty condition. Is empty condition, which is that there is no element in the stack. If there is no element in the stack, it is impossible to delete an element from the stack. So we call that condition as the underflow condition. So overflow condition means stack is full. Underflow condition we call it as the stack is empty. So here what we do is first we will decrement the top value. Suppose if I am deleting the particular 40 from the stack, means what I will do is I'll decrement the top value. So how we will display the stack is I'll display for I is equal to 0. to top. Up to top only I'll decrement the I'll display the value, which means that if the top is at if I was deleting 40 means right now the top is 3. So if I'm popping 40 means what happens? Obviously I cannot pop the selected element into the stack. Only the top element from the stack will be popped. So what I will do is first I'll decrement the top value. So right now my top value is 2. So I'll decrement the top value and I'll pop 40, which top value will be 2. So element only 10, 20 and 30 will be in the stack, which means here one more thing we have to get clarity is here we are not deleting any value at the top at that particular position. Suppose here top is equal to now the stack is 4 means what happens is the 40 will be available at that stack only. But what happens is suppose now imagine this the second position, my top value is 2. So if I want to insert one more element, if I want to insert 50, what we do first we will increment the top value. So the top value becomes 3 and at this position top value becomes 3 means this is the position, isn't it? At this position what happens, I'll override the 40 to be 50. So the value we are not erasing, we are just incrementing and decrementing the value. If there is already the value exists means what we will do if while pushing we are we are overriding the value. That happens over here. Now the implementation of the stack. How can we implement a stack? There are two types of implementation, that is array implementation and linked list implementation. These are the two implementation of the stack, and the implementation part we can see in the next video. Thank you for watching the video.